Hi guys. Okay, so we're going to come back to doing some limits algebraically. So here, if we try to plug 4 into this equation for x, we're going to get 0 over 0 again. Now remember at the beginning of the year when I told you I didn't need you to rationalize all your denominators, that was something that the Regents Board made you do in Algebra 2 because they needed you to learn the tool, the method, so that we could use it later on. I don't need your trig values rationalized when you get 1 over radical 2. I don't need that rationalized. What I need you to be able to do is to rationalize something like this. But we're not going to rationalize the denominator in this case. We're going to rationalize the numerator. We're going to multiply by the conjugate of the numerator, which is radical x plus 2 over radical x plus 2. And this is the limit as x approaches 4. Now, little hint here. If I'm rationalizing the numerator, do not multiply out the denominator. It will just complicate your life and make it harder to solve the problem. Do not multiply it out. Now, in the top, radical x times radical x is x. Now, the whole point of doing this, the conjugates, remember, is we're going to get 2 radical x, and then we're going to get a negative 2 radical x, and those two terms are going to add to 0. And finally, negative 2 times 2 is negative 4. So all of this, and if you wanted to skip that step that we just did because you don't want to write down the plus radical 2x and minus 2 radical x, that's fine if you go right to the x minus 4 over the quantity 4 minus x times radical x plus 2. Now, can this be simplified? Oh, almost, right? These two, this and this, they're similar, but they're reversed around a subtraction sign. When you reverse around a subtraction sign, remember, that's like having 5 minus 3 is 2, and 3 minus 5 is negative 2. What do they divide to? Negative 1. That's right. So these cancel out to a negative 1. Okay, so now we have the limit as x approaches 4 of negative 1 over the square root of x plus 2. We can do substitution. Negative 1 over the square root of 4 plus 2. That's negative 1 over 2 plus 2, or negative 1/4. Yay, you did it with rationalizing. Okay, now there is another way to do this. You could have done this with factoring. I just don't think most of you would have realized this at first. But this definitely can be done with factoring. Obviously, I'm not going to factor the square root of x minus 2. But the bottom, 4 minus x, that's a difference of 2 squares. Remember, guys, it's a difference of 2 squares, not a difference of 2 perfect squares. What multiplies by itself to give you 4? That would be 2 and 2. We need a plus and we need a minus. What multiplies by itself to give you x? That would be the square root of x and the square root of x. Aha, we factored it. Now again, the top piece and this piece, 2 minus radical x, they're switched around to negative. They're going to divide to negative 1. So now we have the limit as x approaches 4 of negative 1 over 2 plus square root of x. Wow, that looks an awful lot like the last problem. We substitute negative 1 over 2 plus radical 4. That's negative 1 over 2 plus 2 equals negative 1/4. Now it's up to you which method you like. I personally don't care. I don't care which one you use, okay? It's up to you, whichever's easiest for you. So let's look at another example. So we have the limit as x approaches 25 of the square root of x minus 5 over 25 minus x. Now what we're going to do is we're going to try rationalizing. So we multiply by the square root of x plus 5 over the square root of x plus 5. So that's the limit as x approaches 25. We are not going to multiply out in the bottom. 25 minus x times the square root of x plus 5. We're going to multiply in the top. Radical x times x is x. Radical x times 5 is 5 radical x, but then I'm going to get a negative 5 radical x, which is going to add to 0. And then negative 5 times positive 5 is minus 25. Okay, do we have any matching factors? No, but these are reversed around a subtraction sign, so they do divide to a negative 1. So this is the limit as x approaches 25 of negative 1 over the square root of x plus 5. So we substitute negative 1 over the square root of 25 plus 5, which is negative 1 over 5 plus 5, which is negative 1/10. And we have our answer. Now, if you prefer to do the factoring method, okay, we would say this was the limit, and as x heads to 25, we're going to keep square root of x minus 5 on the top, and in the bottom, what multiplies to 25? That's 5 and 5, plus and minus what multiplies to x and radical x. And now we have these two factors are switched around a subtraction sign, so they divide to negative 1. So we have the limit as x approaches 25 of negative 1 over 5 plus radical x, which is negative 1 over 5 plus the square root of 25. And notice this looks an awful lot like what we did up here, and we're going to get the exact same answer. Awesome. Okay, so to sum it up, when we're finding limits algebraically, do substitution first. This is the first thing you try. If you get 0 over 0, you're going to try to factor, simplify, and then substitute. If that doesn't work, you can rationalize the denominator or the numerator. Then, of course, you're still going to have to simplify, then substitute. You might remember this flowchart from last week. Okay, we looked at how to start. When you substitute, does the answer exist? Yes, then you're done. If the answer doesn't exist, then no, you're going to algebraically manipulate. That means you either factor algebraically and simplify and reduce. If the answer doesn't exist, you're good. Now remember that algebraically manipulate could be factoring. It can also be rationalizing. So that's what we're adding to that flow chart, okay, is rationalize. Let's try a new problem. You ready for this? So we're going to do the limit as x approaches 0 of the square root of x plus 1 minus 1 all over x. If I plug in 0, I can see right away the bottom is 0. Well, look at the top. That would be the square root of 1 minus 1. That's also 0. So we have 0 over 0. So we have choices here. This is probably one I am not going to factor. I'm going to rationalize this one. So this would be the square root of x plus 1. And instead of minus 1, we're going to make it plus 1. But whatever I do to the top of a fraction, I have to do to the bottom, so that in effect, all I've done is multiply by 1. And I haven't changed the value of everything. Don't forget to keep writing that limit. Okay, reminder, don't forget to keep writing the limit until you do the substitution. On the bottom, we are not going to multiply that out. It's x times the square root of x plus 1 plus 1. Now, in the top, the square root of x plus 1 times the square root of x plus 1 is x plus 1. When we do this and this, those products are going to add to 0. Then negative 1 times positive 1, that's negative 1. So now we have the limit as x approaches 0 of x plus 1 minus 1 is just x all over x times the square root of x plus 1 plus 1. Can you see why I told you not to multiply out the bottom? Because now I can divide to a positive 1 this time. All right, so now we have the limit as x approaches 0 of 1 over the square root of x plus 1 plus 1. Now we substitute 1 over the square root of 0 plus 1 plus 1. 1 over 1 plus 1, which is 1/2. Okay, so here we go. We are definitely going to get 0 over 0. So we're going to multiply by the conjugate, which is the square root of x plus 4 plus 2. And whatever we do to the top, we do to the bottom. So now I have the limit as x approaches 0. I'm going to keep my bottom, x times the quantity, the square root of x plus 4 plus 2. And in the top, square root of x plus 4 times square root of x plus 4 is x plus 4. And when I multiply these two terms and these two terms, they're going to add to 0. Whoops. And negative 2 times positive 2 is negative 4. So now I'm looking at the limit as x approaches 0 of x all over x times the quantity, the square root of x plus 4 plus 2. The x's are going to divide out to 1. That's going to leave us the limit as x approaches 0 of 1 over the square root of x plus 4 plus 2. So we have 1 over the square root of 4 plus 2, which is 1 over 2 plus 2, or 1/4. All right, guys, we did quite a lot today. Good luck, and hope everything's going well.